Okay, so welcome back. This is our next unit here, or next lesson, I should say, on exponential decay. You hopefully looked already at the exponential growth lesson prior to this. Again, this is from the unbounded curriculum. Your teacher should have given you, one of these student versions of the lessons for you to fill in as we go along here. So, Malik bought a new car for $15,000. As he drove it off the lot, his best friend, Will, told him that the car's value just dropped by 15%, and that it would continue to depreciate 15% of its current value every year. If the car's value is now $12,750, according to Will, what will its value be after 5 years? Okay. So we're asked to complete the table below to determine the car's value after each of the next 5 years, round each value to the nearest cent. Okay, so let's do this. So you can already see that year 0, number of years t passed since driving the car off the lot. Okay, so after 0 years driving the car off the lot, that's right after driving the car off the lot, we have the price of the car, $12,750 that Malik paid. There is 15% of that car's value, okay, which is, again, you just do 0.15, which is 15% as a decimal, times the original value there, and you get this amount that it's depreciating. And then the car value minus the 15% depreciation. So you take this money off the car value here, and you get this quantity. Okay, so let's try another one. So here we have 10,837.50, which is just from the previous, depreciation that we calculated. And now we're going to find 15% of that. So 10,837.50. Okay. So 10,837.50 times 15%. So 0.15. And we get 1625.63. We're going to have to round that decimal there. So 1625.63. Okay, and now we'll subtract these two quantities to get our current car value after a year. Oops. And I'm just going to go ahead and do that. You guys know how to type that in your calculator if you want to. Okay, and so we get $9211.87. Okay, now we'll do it again. Right, we're just going to fill in the rest of this table as we go here. Okay. All right. So then, we'll rewrite this one right here. So that's the car's value coming into this. We'll find 15% of that. So again, 0.15 times 9211.87. I get 1381 point, and I'm going to round to 78. Okay, again, subtract these two. And we get 7,830.09. Okay, and continue the process. $1174.51. Okay, and then we get the value here is 6,655.58. Okay, rewrite that here. Okay, again, find 15% of that. $998.34, we'll say. And again, subtract. And we get 5,657.24. Okay, and then bring it over here. Times 0.15, I should say. 848.59, we'll say. And again, subtract for our final value there. $4,808.65. Okay, so much like in the previous example where we had that rare coin, so the previous lesson at the end where we talked about the rare coin and it grew in value, this also is a little bit, uncertain. We can't always predict that the value of a car will drop 15% every year. You can pretty much guarantee that the value of a car will decrease. Especially the newer it is, it tends to decrease more and more in value. Okay. That being said, if you take care of the car and you hold on to it for long enough, eventually it may go up in value somewhat too. But that can take a very long time, years and stuff like that. Okay. So anyway, there's our final value right there. Okay. So this asks us to now write an explicit formula for the sequence that models the value of Malik's car T years after driving it off the lot. Okay. So unfortunately, I don't really think that this method here really shows us, an easy way to come up with a value. In the next video, we'll answer some of the rest of these questions.